Hello. So we're doing lesson 4.3 on multiplying and dividing monomials. Okay, so we are going to work on product of powers property. Let me quickly go over, before we go over the property rules. If I have 2 times 2 times 2 times 2 times 2, let's do more. That's same thing as 2 to the power of 5, right? So if I have 2 times 2 times 2 times 2 times 2, that's 2 to the power of 5, and I multiply this with 2 times 2 times 2, okay? That's same thing as 2 to the power of 5, and then times 2 to the power of 3, right? So that's 2 to the power of 5 times 2 to the power of 3, because you've got 3 of those right there, right? So when you combine them, okay, common mistake. Intuitively, you may think, oh, make this 4. 2 times 2 is 4, and then 5 times 3 is 15. And this is very wrong. Okay, let me show you why this is very wrong. Because, so we grouped these, hold on, let me get a different highlight. Yeah, we grouped these guys together, and we said that that's 2 to the power of 5. And then we grouped these guys together, and we said that's 2 to the power of 3. And when you put them all together, okay, don't group them, but get rid of the grouping, and you put them all together, this turns out to be 2 to the power of, that's 5, and then 3 more, 8. So this turns into 2 to the power of 8. So pattern is actually, if you have 2 to the power of 5 times 2 to the power of 3, to get 2 to the power of 8, you notice how you get the same, you keep the same base, okay? You keep the same base of 2, and then your exponents, you're adding them up. So 5 plus 3 becomes 8, okay? And that is the rule we are going to apply today, product of powers property. When you have the same base, powers with the same base, so these have A for the base, and then you have the exponents, for your final answer, when you simplify them, you are going to add the exponents like that with the same base. Your base stays the same. You don't multiply A and A, okay? So for example, with numbers, if you have the same base of the 2 and you've got exponents 4 and 3, again, you keep the same base. You don't go 2 times 2 is 4. You keep the same base of 2, and then you'll add the exponents 4 and the 3. So it becomes 2, the same base of 2 to the power of 7, okay? And that is the product of powers property when you multiply 2 powers. Okay, so before you get to that, let me go over this thing right here. I guess we can go over this. We call that exponents are used to show repeated multiplication. Okay, so we talked about in the previous lessons how that equals 10 times 10 times 10 times 10, and that's 10 to the power of 4. Okay, and it's the same way even if your base is not 10. Okay, with any base, you will add the exponents. Okay, let me give you the definition of a monomial. Monomial is a number. It could be a variable, or it could be a product of numbers and or variables. Oops. Okay. All right, so let me give you some examples of monomial. It said monomial can be let me use a different highlight, a number. So you could have, I don't know, like number 7. That's a monomial. It could be a negative number, negative 11. That's a monomial. It could be a variable. So x, y. Okay, those are monomials also. Or it could be a product of numbers and or variables. So it could be 2 times x, so 2x. Or it could even be negative 13 times x times y times z. There's a lot going on there, but this is still considered monomial. By the way, the prefix mono means what? That's right, 1, okay? So these are still considered one term, okay? I mean, it's obvious the 7 is one term, negative 11 is one term, but it's not so obvious that we make negative 13 xyz one term. It's still a monomial because it's joined by multiplication. As long as it's a product, it's a monomial. Then what's not a monomial is simply x plus 5, okay? So these numbers have to be joined by multiplication. It's got to be a product. In this case, it's an addition, so this is not a monomial. This is two terms, actually, so this will be considered a binomial, which we'll talk about later, okay? So there is that. Subtraction, same thing. You can't have like 2 minus y. That is not a monomial. That would be binomial, okay? All right, let's get to some problems and practice multiplying powers. So same base. So this one, same thing, base. But you know what? Just for the fun of it, let's expand this out. 4 to the power of 3 is 4 times 4 times 4. And then 4 to the power of 5 is 4 times 4 times 4. How many is that? 3, 4, and 5. Oops, I almost wrote 5. 4. Okay, so 5 4s and 3 4s. So all together now we have how many 4s? We got 7 4s. Okay, so we can expand it out and it makes sense. Or we can just simply do now, follow the rule 4, same base to the power of 3 plus 5, which gives you 4 to the power of 7. Okay. All right, next one. So we're just gonna use the rule without expanding it, okay? So this one we have same base of 12. Add the exponents, it's 3 plus negative 2. Be careful with the negative. So this is 12 to the power of 1, and that's it. Okay, or you can just write this as 12 because it's kind of silly to do 12 to the power of 1. Number 3, again, same base of m. So m, and then you add your exponents, 5, negative 2, and 3. So that's going to be 5 plus negative 2 plus 3. And that's m to the power of, what do we have? 3 plus 3, that's to the 6. And that's my answer. And this is the only work I require from you guys. Okay. Number 4. So it gets a little bit more difficult, but that's okay. Okay, so these are all products. These are all joined by multiplication. So we can put the numerical parts together, your coefficients together, and multiply them. So negative 2 is multiplied with 6. And then power with the x as a base is multiplied with another one with the x as a base. So negative 2 and 6 are multiplied to negative 12. And then you have the base x to the power of 6. Okay, I hope you're finding this easy and easy to understand. All right, here. This is going to get really tricky, but please understand that without the parentheses around this, then negative 4 is not raised up to with the base negative a, okay? The base for this negative 4 exponent is just the a, not the negative portion. Again, if you see parentheses around negative a like this, and then it's raised to the power of negative 4, that will mean it's negative a times negative a times negative a times negative a. But the way they have it without that parentheses, this is the same thing as negative 1 times a to the power of negative 4. Okay, so pencil in the negative 1 as a coefficient for that monomial. Okay, so it's negative 1 times, I'm going to multiply all my coefficients first. So negative 1, 3, and 2 are going to be collected together. So negative 1 times 3 times 2. And then I'm going to collect all my powers, okay, all the purple highlighted parts, and then a to the power of negative 4. I'm going to just combine my exponents right now. Plus this 2, plus, remember, this is not 0, okay, this is 1 like that, okay. So negative 1 times 3 times 2 is negative 6. And from these together, okay, when I combine my powers, what do I get? Negative 2 plus 1 is negative 1. So I end up with times a to the power of negative 1. Okay, math convention. Please do not leave your final answer with a negative exponent. We want to turn it into positive exponent. And again, only a is raised to the power of negative 1. So to turn that into a positive, remember, you got to bring it down. Okay, so negative 6 stays on the top because it's got a power of 1. And then a comes down. So that's your final answer right there. Okay. All right. If you're confused about this one, this is a quite challenging one. I suggest that you rewatch this portion of the video. All right. Number 6. If you want to pause the video and try this on your own, that might be a great idea. Okay, so I'm going to collect my coefficients, 6 and negative 8, and multiply them together first. And negative 8, let's put parentheses around that. Okay, and then let me collect all my x's, x and x there. Let me color coordinate this for you guys. X, not with a highlighter. X to the power of 1 times x to the power of 2. So I took care of the coefficients, I took care of my x's. Now I have my y's remaining. So y to the power of 3 times y to the power of negative 6. Okay, so it's a good idea to put the ones with the same base next to each other. So that way, hopefully we can minimize the number of mistakes we make. So 6 times negative 8 gives you negative 48. And x, we have 1 plus 2, that gives you 3, so x to the power of 3. And then y, we have 3 plus negative 6, that's negative 3. Okay, and please remember, you don't want to have anything with a negative exponent on the top. So negative 48 x cubed stays on the top, but this one with a negative exponent should come down to the denominator, and it becomes positive. So y to the power of 3. All right, so that's that. Okay, let's look at the next example. Next one, so that was product when we were multiplying powers. Okay, it was product. But what if it's a quotient, meaning you are dividing instead of multiplying? You've got like a to the power of m divided by a to the power of n, or 3 to the power of 6 divided by 3 squared. So this one, you do the opposite. You'll be subtracting the exponents. Let me show you what I mean by this, okay, with an example. So I'm going to show you this one. 3 to the power of 6 divide, remember division can be expressed as a fraction bar right there, divided by 3 square. If I expand this out, that's 3, 3, 3, 3, that's 4, 5, 6 threes all over, 3, 3. At this point, I can cancel the 2 threes. So I'm left with 4, 3. So this is 3 to the power of 4, okay? Or simply, you can just do the exponent, the first exponent, take away the second exponent, and you get the same answer, okay? All right, so let's look at the next page. And this is what they're explaining, what we just did, okay? So again, real quick, you can just look at this and go 4 to the power of 5 minus 2, and that equals 4 cubed. Or, again, it helps to kind of visualize, expand it out. 4 to the power of 5 means there are 5 fours. And 4 squared means there are 2 fours. And again, as you can see, they canceled out 2 sets of 4s, and you're left with 4 cubed. Okay, I hope that makes sense. I'm going to expand out first couple, and then I'll start using the rule, okay? All right, it's always helpful to visualize this. So 8 to the power of 5 means there are 5 8s, 1, 2, 3, 4, 5. On the denominator, I have 8 squared, which is 1 and 2. So again, you can see how these 2 sets of 8s can cancel out, and you're left with 3 8s, that's 8 to the power of 3. Using the quotient rule, we could have done 8 to the power of 5, take away 2. And that again gives you 8 to the power of 3. Okay, easier way to do this. All right, number 8. One more, expanding it out. Okay, that's C, 3, 4, 5, 6, 7, all over C. You cancel out the 2 C's on the top and the bottom, and you're left with C to the power of 5. Okay, I hope you're getting the hang of the rules. Oh, you know what? This is a good one to just expand it out one more time, okay? Or I'll do both ways. So, this is a negative exponent, which means you got to bring this down, okay? So, what used to be on the top is going to go down. So, let me just rewrite this 2 squared. So, 2 squared is rewritten. And let me color coordinate now. The 2 to the power of negative 2, now it's going to come down as 2 to the power of positive 2. And what remains on the top? Nothing. So you're going to put 1. So this turns into 1 over. Now this turns into a product rule. So 2 to the power of 4. Okay? All right, let's do this with using the quotient rule. So over here, it's same base 2. And remember, for your exponents, you got to do the top exponent minus the bottom exponent. Top exponent is -2, and the bottom exponent is 2. And you got to, again, subtract the bottom exponent. This is 2 to the power of, we got to do plus the opposite, and that turns into -4. And remember, your answer cannot be in negative exponents. You turn this into 1 over 2 to the power of +4. Okay? And as you can see, it's the same answer. All right, number 10. We're just going to use the quotient rules now. D to the power of top exponent minus the bottom exponent. Okay, it's minus negative. It's double negative. So it's going to turn into plus positive, and that's d to the power of 8. Okay, this one. All right, we've got a combination of things. So again, think of separate the coefficients from the powers with the same base. Okay, so I just separated my coefficient from my powers with the same base. Okay, and then simplify them separately. 5 over 15 gives me 1/3. And from this, I get u to the power of 4. Okay, I can rewrite this as a single fraction, u to the power of 4 all over 3. Okay, and that's my final answer. All right, one final example. Okay, we got a lot going on there. Let me color coordinate this for you guys. So there is the coefficients. Oopsie, that's not the same color. And then we've got your base x, and then you got your base y. Okay, so -9/27 times x to the power of 4 over x cubed. I'm just making a little more space in between. And then y to the power of -2 over y to the power of -4. Okay, use the space to rewrite things more clearly for yourselves. So from this, it's just 9/27. So you simplify it. Okay, divide top and bottom by 9. You end up with -1 over 3. You do 4, take away 3. So x to the power of 1. Ooh, this is a little tricky, so I'm going to rewrite this. Y to the power of -2 minus -4. When it comes to complicating things like this with a lot of negatives, do what I just did and rewrite it. Write it out, okay? So now this turns to plus, positive. Okay, so let me write my answers all together. It's going to be a fraction, and I have a -1 there, and 3 down here. And then x to the power of +1 stays on the top. Okay, notice I'm not writing this 1 there because you don't need that. Okay, and I'm not writing this 1 either because you don't need that either. And then let's figure this. That's y to the power of +2. So that one should also stay up there. Okay, please don't think that you have to bring this down because it's negative. This is not a negative exponent. It's the x number that's negative, and that's okay. You can keep it on the top. Only if you were to have like a -2 exponent, then you got to bring it down. But this is all positive, so we're good. All right, so I hope that makes sense, and that brings us to the end of our lesson for today.